Hello student, in this video we will study about the bonding theory about for AB5 type of molecules, and here is the first example is like phosphorus pentachloride. So far we have studied in the previous chapters, previous video that about for AB2 type linear electron and molecular geometry will be there, and in case of AB2 it will be trigonal planar, in case of AB4 tetrahedron, and now we are going to study about these two, AB5 which is trigonal pyramidal and AB6 which is octahedral. So we will see here first about AB5 type, and here is a first example, AB5 type PCl5. So first you have to draw the Lewis structure, and then you can see that there are 5 atoms bonded to the central atom, 1 2 3 4 5, and there is no non-bonding electron on the central atom. So the electron pair geometry and molecular shape will be the same, which is trigonal bipyramidal, and the bond angle will be 120 and 90 degree. So this is not correct representation for the bond angle purpose. I will show you in the next slide how we can draw this correctly. And molecular geometry is the same as the electron pair geometry because there is no non-bonding electron pair on the central atom. So let's see some example of this one, and in the chart so we can understand better. These are some other examples for AB5 type of molecular bonding: PCl5, SF4, ClF3 and xenon difluoride. So here you can see, once you will write the electronic configuration, Lewis structure of these one. So if number of electron domain are 5, so electron domain geometry will be trigonal bipyramidal, and there will be bonding domain 5, non-bonding 0. So molecular geometry will be trigonal bipyramidal, and in case of example is PCl5. So you can see and it has 2 bond angle. So in case of PCl5 we can write like P phosphorus in the center, and then 1 chlorine on the top, another chlorine at the bottom, and then make a triangle from here, this like this one and this one. So these 3 chlorines will be in the one center, one plane. So these chlorine will be in one plane, and the bond angle between these two will be 120, and these two will be 90 degree. But in case of SF4, where is sulfur tetrafluoride, when you will write down the Lewis structure of this one, you will notice that there is a one lone pair or one non-bonding domain is there, and 4 domains which are bonded. So one lone pair will be gone, and this will become seesaw structure. So electron pair domain geometry will still remain same, trigonal bipyramidal, 1 2 3 4 5, but molecular shape will become seesaw. In the third example, which is a trifluorochlorine, so in case of this one, when you will draw the Lewis structure of this one, so you will notice that there are 3 bonding domains and 2 non-bonding domains are there. So and the shape will be called T shape, and in case of if there are 3 non-bonding domain and 2 bonding domains are there, so in case of xenon difluoride, so this will become linear shape. So these were the example about the AB5 type. So you must practice to write down the Lewis structure of these one so that you can understand better. And let's study about the next type, which is AB6 type of molecular geometry. So once again we will review about our typical slide, where in case of AB6 you can see there the 6 elements are in, out of the 6 elements 4 elements are in one plane in the form of a square, and 2 are just like a linear fashion. So they are like AB6 type of, and the molecular geometry and electron pair geometry is for 0 non-bonding domain is octahedral, and the bond angle between these two will be 90 degree, and these two also will be 90 degree. So here is another example, which is Sf6 Sulfur Hexafluoride. So when we will write down the Lewis structure, we will notice that the 6 atoms bonded to the central atom, 1 2 3 4 5 6, and no non-bonding electrons on the central atom. So octahedral molecular geometry and octahedral electron pair geometry will be the same, and molecular geometry is the same as the electron pair geometry. So this red is shows the electron pair geometry. So let's see some other examples in this case of AB6 type of molecular shape. So other examples include Sf6 Br5 xenon tetrafluoride. So here is a important question, that how we will know that this molecule will adopt which type of geometry, molecular geometry or domain geometry. So you will get the answer once you will write the correct Lewis structure. So first step is always write down the Lewis structure, correct Lewis structure, and then find out how many bonding domains are there and how many non-bonding domains are there. So if 6 bonding domains are there, then the electron geometry will be octahedral, and example is Sf6. So sulfur will be in the center, and then these 4 fluorine will be in one plane, and the 2 fluorine will be, one will be on the top and one will be at the bottom. So they will be like this one, and the bond angle between, so they will be in one plane like this. So bond angle between these two will be 90 degree, and these two will also be 90 degree. But in case of, if there is one non-bonding electron, non-bonding domain is there, then the shape changes, it called square pyramidal. An example is Brf5, and if there are 2 non-bonding domains are there, then shape will be called square planar, because only these will be remain as such. So these are the some examples for the AB6 type of electron domain geometry and molecular shape. So please review all these type of molecules and write down their Lewis structure to see what will be the electron geometry and how many bonding domains will be there, how many non-bonding domains are there, and what will be the molecular geometry and bond angle. So this is important for this type of molecules to find out the electron geometry. Okay, in the next video we will study about the polarity of the molecules.